An essential part of the NICA complex program is the research being conducted on the innovative application of charged particle beams. For the NICA complex, this research is motivated not only by its importance, but also by the properties of the accelerator complex. The fundamental research facility is the collider. How does it work? Within a few minutes, it is filled with a beam, after which several hours of experiments are conducted. The rest of the accelerator facilities are superconducting. This means that they have to operate constantly, otherwise the energy for producing liquid helium would be wasted. That is why, parallel to fundamental research at the collider, we need to conduct applied research on the beams extracted from the nucleotron between filling the collider. The program of applied research is now in the process of being formulated. We have a historically established field of research related to radiobiology and the development of techniques for the medical application of beams. To date, an agreement has been concluded with Roscosmos on the testing of microcircuits and the creation of a new line to test satellite microcircuits. Our institute has good experience in that area. Microcircuit testing has been done before in the nuclear reactions lab of our institute, using the nuclei of heavy elements with relatively low energies, as little as several dozen of mega-electron volts. Our accelerator complex makes it possible to further develop this research at higher energies, from a few hundreds of mega-electron volts to several giga-electron volts per nucleon, which is equivalent to the energy of accelerated particles. In addition, we plan to continue the research which has historically been conducted for a long time at the nucleotron. This research is focused on new technologies, on the recycling of nuclear power plant waste, and on the utilization of accelerated beams for new methods of energy production. It is also focused on the technologies related to the so-called systems of controlled beams of nuclear reactors, or accelerator-driven systems. Finally, one more important component of the NICA complex program is its education program. Here it needs to be said that such a program is a distinctive feature of any mega-science facility. It has to be emphasized for NICA. Any facility of a large scale has, firstly, a long period of development, and secondly, no facility is planned entirely for one physics program to be realized on a single occasion. As part of the implementation of the NICA project, 3 consecutive modernizations of the complex have already been planned in combination with changes of the physics program, which has already been drafted until around the year 2030 and 2035. What is consecutive modernization? It is the development, production, and assembly of the beam facility along with the testing of certain electrophysical equipment. The period of development and commissioning can be 2 to 3 years, which corresponds to the preparation of a master's, doctoral, or postdoctoral thesis. Thanks to these specificities, any accelerator center and any mega-science facility in the world is also considered a training center for the industry. People joining such institutions, regardless of their country of origin, perform specific and highly qualified jobs, can go on to obtain a certificate of education, and find work in similar sectors of the economy. Consequently, our complex is an accelerator complex. Specialists can be trained in our complex to work in many areas of science and technology, such as industrial electronics, vacuum engineering, radio frequency physics and technology, of course in physics and technology related to accelerators, superconducting magnetic systems, technologies for obtaining liquid helium, cryogenic technologies, systems of automatic control, particle detectors, and the development of radiation control and radiation protection systems. Besides the fundamental facilities that makes it possible to deliver such education programs, our institute comprises a special division called the University Center. As part of this University Center, courses are offered within education programs in the Russian Federation and in other member countries of the Joint Institute for Nuclear Research. There are regular training programs for students where leading scientists from our institute tell participants about the fundamental facilities of our institute. In addition, a new department based on the lineal accelerator, LINAC 200, was established in 2013. It is a radio-frequency resonant lineal electron accelerator. Workspace has been made available where laboratory work can be done, including the works on vacuum engineering, industrial electronics, radio-frequency engineering, radiation protection and systems of automatic control. The complex is used to organize block seminars for student groups of various universities, which can last anything from 1 week to 1 month, depending on the depth of the material. The first international student group completed their lab work in this complex in the year 2015. Furthermore, our University Center is developing additional educational materials. As part of the University Center, virtual tours of all of the main facilities have been created. I can recommend the tour at our Nucleotron Accelerator complex. There you can see what I've been telling you so far in a live thread. Lastly, I want to show you the view of the construction site of our collider from outer space. The emerging collider building itself has, at the moment, the shape of a horseshoe. Perhaps it is for good luck. And finally, I want to invite you to participate in our project.